I'm sure that you've all heard that this whole event starts with a phone call at 5 o'clock in the morning, and there's this friendly voice at the end saying, you have just won the Nobel Prize. Ho ho. And I thought I'd just tell you the things they don't tell you at that time, and that is where you're being offered a job. There's no salary involved. The working hours typically are 12 hours a day, and there's certain offsets, however, and that is that overnight you'll become world famous, and that you can always hope that perhaps there's no extension of this service. So that's my introduction to this whole situation. Well, it's a great honor to be awarded the Nobel Prize. And it's a wonderful experience for my wife, Betty, and me. We received congratulations by email, phone, and post, many from old friends we had not seen for some time. I found that my career at Bell Labs thrived because of the environment, which encouraged cooperative research, offered opportunities for access to sophisticated equipment, and fellowship. The fellowship was very important when it coupled the skills of a theoretical physicist with an experimentalist. It's not surprising that George Smith's and my Nobels represent the 7th Nobel Awards for Bell Labs. Lester Germer was my first supervisor at Bell Labs. He was the Germer of the Davidson and Germer experiment that is sometimes referred to in introductory texts on physics. During some early work on thermionic cathodes, they were able to show data that the electron could behave as either a wave or a particle. This was key to understanding many atomic scale phenomena in the world of quantum electronics. Germer's main interest outside the laboratories was rock climbing and sometimes mountain climbing when he was on extended vacations. The new boys in his laboratory were expected to participate in his sport at least once. My test came one day when we drove to his favorite spot about 90 miles north of Murray Hill. And this was in New Jersey, and there it was, a 50-foot cliff. The face of the cliff made 90 degrees angle with the road. He started up the hill, hand over hand. He was laughing at me as I stood at the bottom of the cliff with both feet firmly fixed on the highway. And he was laughing at me in this situation. So during the 40s now, a major problem began to appear in the telephone switching network. As the number of subscribers increased, the complexity of the network increased with it, and perhaps even faster. Some of the switching was done manually, and it has been often said that as the amount of switching increased, it required new operators, and pretty soon the whole of North America would be hired as telephone operators. The real problem, however, was the number of electromagnetic relays that were needed. They were big, expensive, and unreliable. I once saw the machine that made them. It was the size of a small steam locomotive and sounded like one. Plastics made their body, and it was a metal plate at one end, and as the machine chugged along, relays came popping out the other. Faced with the problem, the president of Bell Labs, Mervyn Kelly, hired 3 new scientists, a physicist, a theoretical physicist, and a PhD in electrical engineering. I do not know what he said to them, but I don't believe he told them to design a better mechanical relay. Because here we are talking about Bardeen, Shockley, and Bratton. And these people went ahead and explored the transistor effect, and in the process established the whole field of digital electronics. George and I spent a great deal of time thinking and dreaming about possible new electronic devices. We considered both new materials and new structures. For example, the semi-metal bismuth was looked at because of the small effective mass of its electrons. For various other reasons, however, it was not promising, and we dropped it. Our boss, Jack Morton, called me frequently on our picture phones. He was keen about utilizing the new technology of the magnetic bubbles. Could we do something similar in our new devices? And the picture phone was a large piece of equipment that stood on our desks. This is before the time of the CCD. And I would try to get out of his field of view. But as I sank down in my chair, he would shout, he was a powerful man, "Sit up straight, Boyle, so I can see you. If your lab is not more productive, I may have to cut your budget." So with that, the invention of the CCD took place one afternoon over one of our frequent brainstorming sessions at the blackboard. We began drawing a diagram, and before it was finished, we knew we had something startlingly new. And after a few weeks of work, George asked for the shop to make a model of the device. So, somewhat to my surprise, the very first model worked exactly as we'd hoped. And this was the first 3-bit device that emerged from our tests. Sometime later, George and I described this discovery at the Institute of Electrical Engineers, and it had been rumored that Bell Labs was coming up with something new. And these people had come out from the West Coast to see us and see what this new device was. So some people have a succinct way of summarizing events in science and technology. Jim Early, who was the late director of the Fairchild Semiconductor, said, "The transistor worked with the sense of sound, and the CCD worked with the sense of sight," a whole change of the dimension. Over the years, George and I have received congratulatory letters. One was from a group of 20 celestial telescope makers, and it said the CCD had made revolutionary advances in their telescopes, an improvement of a whole order of magnitude. And one night, I was watching a TV. I saw a live photo of the planet Mars. These were boulders and banks of sand. It could have been a desert on Earth. And at that point, I felt a vicarious achievement in extending man's observations out into deep planetary space. Well, now finally, I've given you a little outline as to how things got started, but actually I left out perhaps the most important phase of the starting altogether. And that's in my education in the very earliest stage before I went to school. Because my parents lived in northern Quebec. There was no school system there, and my mother was not particularly trained as a teacher, but she decided that she would just try and see what she could do. So she spoke to friends and found out some interesting books that perhaps I might find useful. And well, I guess two of the books that stand out are by Lancelot Hogben, called Science for the Citizen, and another one called Mathematics for the Million. And these two books were what I used as my Bible when I was being brought up. My mother was not a teacher. She merely acted in the Socratic method and asked me from time to time questions that she found in these books and others, until she was satisfied that indeed I was making progress and going on to the next year. We're now talking about my growing up until essentially the 9th grade of high school. And that was going along quite successfully. And then she began to get worried. Here I was, no children to interact with, all alone, except for some lumberjacks who we went out sledding together and things like that. And so this concerned her, and so she developed this technique of taking me into Montreal, the nearest town, into McGill University, into a university lecture. And as the lecture proceeded, she'd be sitting alongside of me and wondering, now, how does this relate? Oh, yes, she said, I can imagine this, because we told you, you learned about these in Science for the Citizen. And indeed, it was a pretty good education, because she taught me there, first, a little bit of calculus for the mathematics, a little bit of history, Egyptian history, and this formed a real strong background. And she felt that I probably was knowing all that was worth knowing at that time. She felt totally confident that she had done just a superb job of teaching me. And in fact, looking back, here I am, and that's what happened. Something happened in between, I guess, McGill and so on, but nevertheless, it happened. So we went to these various conferences. These are lectures at McGill. And as it was going on, she'd sit down alongside of me, and she'd nudge me this way. And she'd say, listen to what they're saying. Listen to it. You know all that. You know that. So why don't you stand up and tell them who you are? And that's how I got my start in lifetime. I've been going along telling people who I was. And of course it worked, because now I don't have to tell people anymore who I am, because I have a Nobel Prize. That's all I have to say, and I've enjoyed this very much. And I'd be only too happy if there's anyone who would like to offer some thoughts, or if there's time for any discussion, I'm available.
Thank you. Thank you very much.
My pleasure.
And we are a little bit ahead of schedule, so
right.
if I don't think we can have a discussion because we have problems with microphones and so on, but there's one question that I may allow myself to ask you, and that has to do with your work at Bell Labs and the conditions there, because there were a number of labs. I have colleagues who are now in academia who were at Bell Labs and IBM and Exxon and so on and so forth. And there seemed to be very good conditions and a lot of productivity. Can you say something about what it was like to work in an industrial lab, but still producing so much of science and output of that sort?
Absolutely. I think this depended very much on the attitude of top management at Bell Labs. A number of principles. One is that the top management themselves had a background in science, very, very capable. The one, I guess it always stands out in my memory, was Bill Baker, who was a chemist, and he always seemed to know more about whatever subject was up for discussion than anyone else. He was very well read. He understood it perfectly. And so the management of the research, the detailed management, day-to-day purchase of equipment and so on, was done from the ground up. In other words, there was a certain overall budget for the Bell Labs. But then each individual division would get a piece of that, which the people themselves would decide how it was to be divided. So I think one of the most important things is management by the participants. That's number one. The second was perhaps the fellowship. There was a very strong incentive to share information within the organization. In other words, there were seminars locally, and there was a lot of interchange between the theorists and the experimentalists. And I think that also is key. In other words, theorists are fine, and they have their role in our society. But every now and then, you need to couple the theory with the practical. And I think that was done very effectively also in Bell Labs. So there's just some thoughts of what's important.
And to what extent were you able to define the problems you wanted to work on? You indicated that Merton was a little bit pushed you a little bit at one time, but otherwise, could you?
I wish I could,
yourself?
Set out the ground rules for how these programs were decided. But again, it was very much an intuitive feeling of the people themselves. In other words, no one ever came around and criticized you because you might be wasting too much time in some area or another. And the areas that are covered were very broad. In other words, it wasn't all having to do with telephone. I hoped I communicated the idea that when it came to this problem of the switching network, which occupied a lot of the finance and so on, the president hired some physicists and some theorists, and they went in and they didn't try to make better relays, but they just tried to attack the problem from a basic point of view. And it worked, because that's how the transistor got started.
Yes. The competition between, you say you had a lot of contact discussion. Was it friendly competition? I mean, if you would come up with something in terms of inventions and patents and so on, what were the mechanisms of that sort that would have an effect on how you worked?
I think there were certain conditions. In other words, the Bell Labs just didn't have a carte blanche to do anything they wanted. But nevertheless, there was a certain freedom within that general area. And the people, I guess, were interested in establishing patent positions in certain cases, because ultimately you had to justify your existence to the management, where the money comes from.
Yes. Okay, I think we...
Thank you. It's been nice talking to the group. I enjoyed it.
Thank you, thank you. So let's thank Dr. Boyle once more. Please.